Goeiemiddag rotsakke. Welkom by Advanced Program Wiskunde vir graad 10. Right. Today we are starting a new little section on sequences and modeling. We will be working with this textbook, the Mindborn Maths, Finance and Modeling textbook. Right. So, there are two ways, so this falls under the modeling section, there are two ways of expressing a formula for a sequence. The one that you've done before is something that we call an explicit formula, or a general solution. And what this kind of formula, is it generates a term based on its, so it generates a term n based on its position n in that sequence. So in other words, if I said to you, you've got a formula for a sequence and it says to you the value of the term in position n is equal to 4 times its position, which is n, plus 7. Then to find something like term 3 would be simply equal to, so you'd replace n with 3, term 3 would be 4 times 3 plus 7, which would be equal to 19. So explicit formulas or general solutions, if you know the position and you know the formula, you're done. Okay, so for example, term 20 in this formula would be 4 times 20. You just replace n with 20 plus 7, which would be 87. Okay, so that you've kind of done before. You've looked at it in core maths quite a bit. Over here, the next way we're going to look at sequences is recursive sequences or difference equations. Okay, so what they do is they don't generate a term based on its position, they generate a term based on applying some mathematical rule to the term before. So, and sometimes more than one term before. Sometimes you need 2 terms before, sometimes you need only 1 term before. But you need to have terms before in order to get the next term. So you couldn't go straight to a case like this. You couldn't go straight to finding term 20, you'd first have to find term 19. Okay, something like that. So this generates a term by applying a mathematical rule to a preceding term or terms. So an example of a recursive sequence, this is also called, so this is an example of a recursive sequence. Okay. It's also called, in this particular case, it's called a first order difference equation. Okay. So this is also called a first order difference equation. Okay, now why it's called a first order difference equation? A first order difference equation just depends on 1 term before, okay, not on more than 1 term before. Okay, so this is an example of a recursive sequence. It says a term in some position is equal to 5 times the term before. So the term in position n plus 1 is 5 times the term in position n, which is the term before, plus 1. I couldn't generate a sequence with just that information, okay, because where do I start? So in addition to the actual formula, this is glued, this is also part of the formula, what the value of the first term is. Okay, so Tn plus 1, the value of a term is 5 times the term in the position before, plus 1. It's not depending on the position in the sequence, it's depending on the term before. So that's what we mean by a recursive sequence, and we have to tell you where to start. And they say to you term 1 is equal to 2. So, in other words, if you replaced n with 1, then this whole thing would become term 1 plus 1, in other words, term 2. Okay, so this would be when n is equal to 1. And you replace n with 1, and you'd get term 1 plus 1, in other words, term 2, would be equal to 5 times term n, replace n with 1. So in other words, 5 times term 1 plus 1. Right? But we know the value of term 1. Term 1 is equal to 2. So term 2 would be 5 times, there's term 1. Term 1 is 2. So it would be 5 times 2 plus 1, which is 11. Okay? Then to get the next term, term 3, well the term, now I'm saying if n is equal to 2, okay, then if I apply it into that formula over here, n is equal to 2, term 2 plus 1, in other words, I'm replacing n with 2, so term 3 would be 5 times the term in the position before, so So in other words, 5 times term 2, n is equal to 2, okay, plus 1. But term 2 was equal to 11. Okay, so term 3 will be equal to 5 times term 2, which is 11, plus 1, which is going to be equal to 56. Just one thing, you could also write this formula. Say this formula here, term n plus 1 is equal to 5 times term n plus 1. You could also write it as term n, the term in position n is equal to 5 times the term before. Well, if your term's in position n, then the term before will be in position n minus 1. It means the same thing. Here, your term is position n plus 1, the term before will be position n. So it will be 5 times t n minus 1 plus 1. So that and that are saying exactly the same thing. They're both examples of recursive sequences. Okay, well, it's the same recursive sequence, just expressed in a slightly different way. That one is the same thing as that one over there. Right, ladies and germs, get all of that down, please. Sunny banane. And we are back. Right, so expressing arithmetic sequences. Okay, so we're going to look at a specific type of arithmetic sequence now. We're going to look at a specific type of sequence. We're going to look at arithmetic sequences. Okay, you should have come across arithmetic sequences before in core. Arithmetic sequences have a constant fixed difference between each term. Okay, so arithmetic sequence have a constant difference. So we're going to have a look at how you would express an arithmetic sequence in explicit form. What's an explicit formula? It generates the value of the term based on its position n. You've done that before. And then we're going to look at how you would write an arithmetic sequence as a recursive formula. Okay, what is that? It's a formula based on the value of the term before. Okay, and another name for a recursive formula is a first order difference equation. Righty then. How's it going there, ma'am? Well, it's going well in the music department. Right, so, okay. We're going to look at the same sequence. 3, 5, 7, 9, 11. Okay, and we're going to look at it explicitly and recursively. So first of all...
Sir, you have a horn on your head.
I have a horn on my head. Yes, yes. Okay, there's a comment I could make, but I shall not. Right. So I've got 3, 5, 7, 9, and 11. First of all, why is this an arithmetic sequence?
Oh, you could make...
Shh. Okay. 3, 5, 7, 9, 11. Right? So what are you doing to get from one term to the next? You are adding 2 in each case. Okay, so that's why that's called an arithmetic sequence. It's also known as a linear sequence because if you plotted it, it generates a straight line graph. So if you've got an arithmetic sequence and you want to express a general solution or a general formula or a general term, anything to do with the word general, okay, then you can either go use, some of you might have seen the formula Tn is equal to a plus n minus 1d. You can use that with pleasure. What I tend to do is just do this. I say, right, the difference is 2. So 2 is going to be the whatever the difference is. In this case, the difference is 2. That's going to be the coefficient of n. And then I just balance. So if I sub in n is equal to 1, at the moment I'll get term 1 is 2 times 1, which is 2. Just look at term 1. But term 1 should be what? The value of term 1 is 3. So at the moment, if I put in n is equal to 1, I'll get term 1 is equal to 2 times 1, which is 2. But I want to get an answer of 3, so I've got to add 1. Always check if it's working. So I know, let's for instance, term 4, it's given that term 4 is equal to 9. So if I sub in n is equal to 4, I should get 9. So term 4 is going to be 2 times 4, which is 8, plus 1, which is equal to 9. So it seems to be working. Lovely stuff. Right. Now, go find the value of term 20 by using that formula. The question says determine T20. So to find T20, it will simply replace n with 20. And it's 2 times 20 plus 1, okay, which is equal to 41. So this is what we call an explicit formula, because what does it do? It generates the value of a term in a sequence based on its position n, right? Okay, so term 20 is 41. Let's look at that same sequence, videos, starting to get a bit tired of them, okay, as a recursive sequence, but no doubt the audience are riveted, okay, and as a recursive sequence or a first order difference equation, first order difference equation means it depends on only one term before it, okay, so now, yeah, you actually could, hello, here comes a crocodile, or a wolfie, to eat term n plus 1. Right, okay. So, in a recursive sequence, right, quiet now please. Okay, what are you doing, okay, to get from the preceding term to the next term? Well, it's not rocket science, you're adding 2. So the term in position n plus 1, or the term before position n plus 1 is tn. So to get to the next term, it's the term before plus 2. Easy peasy, lemon squeezy. That is the recursive sequence, or the first order difference equation. It depends on one term before. Okay, this wouldn't be enough to generate that sequence because we wouldn't know where to start. So you also have to write down, you'll lose a mark if you don't write this, that term 1 is equal to 3. That's just given, but you've got to repeat it there in the formula. Okay, so that and that, those things combined, make up the formula, because from that I can generate that sequence. Okay. Term 2 would be equal to term 1 plus 2, which would be 3 plus 2, which would be 5. And the next term would be 7, etc. It's just saying add 2 to the term before. In some books, sometimes you should perhaps write n is a natural number, but I think it's kind of implicit if you're working with sequences. I'm not going to show you this every single time. You could also write the sequence as, if you call a term n, then the term before would be term n minus 1 plus 2, and term 1 would be equal to 3. That and that are saying the same thing. They're saying the value of a term is the term before plus 2. The value of the term is the term before plus 2. So that is your recursive formula, or first order difference equation. Now, to find term 20, okay, is a bit of a mission. I mean, we can keep going, so we know you've got 3, add 2, 5, 7, but to get to 20, okay, can be a bit of a pain in the bum. To save a little bit of time, especially when you get to more complicated recursive sequences, this is what we're going to do. Okay, get your calculator out. Okay, so on your calculator, I don't know if you can see this here, probably not. Okay, so on your calculator, maybe it's better over there. Okay, what you're going to do is this. You're going to go, take your first term, okay, which is 3, and you're going to go 3, right? Then you're going to press equals. So you're going to go 3 equals, right? Now by pressing equals, it's stored in the calculator under the answer button. Then clear the screen, so press AC. So you've got a blank screen now, but 3 is stored in your calculator with the answer button. So now, to generate the sequence, you're going to go answer, so you press answer, okay? And what do you have to do? Add 2. So this is going to take every answer and add 2. And you can keep this, so if I press equals now, I get 5. Now you've got to count literally on your fingers. So term 2 is 5. If you press equals again, it will add another 2. So term 3 is 7. So I'm up to 3. Okay, and I've got to get up to 20. So I'm at 3, which is 7. So keep pressing. 4, 5, 6, 7, 8. I'm pressing the equals button. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And you should hopefully, after pressing the equals button the correct number of times, see that your answer is indeed 41. So it generates the same answer recursively as it did explicitly. Okay, so when you're going to ask to find the value of a term quite far off in a recursive sequence, you're going to have to use that method. What do? Put term 1 in, clear it, okay, so it's stored in your calculator, and use your answer button, and then apply whatever rule you're doing to get from one term to the next. Okay, right, hope that makes sense. Get that down, asseblief. All right, humans. Okay, so we had a look at expressing arithmetic sequences in recursive and explicit form. Arithmetic sequences, remember, you are adding a fixed number to get from one term to the next, adding or subtracting. Okay, we're going to have a look now at geometric sequences, okay, which are also known as exponential sequences. And to generate an exponential sequence or a geometric sequence, what you have to do is you have to multiply a term by a fixed, the preceding term by a fixed number. So, a geometric sequence or an exponential sequence, you multiply by the same number. That number you're multiplying by, okay, the notation we're going to use for it is R, the common ratio. Okay, you get it by taking one term and dividing it by the term before. So, if you multiply by the same number R to get from one term to the next. So, they're pretty straightforward. So, an example of two types of geometric sequences. You've got 5, 20, 80, 320. Okay? So, what are you doing to get from one term to the next? Well, you are timesing by 4. Okay, timesing by 4, timesing by 4. Okay, so you're multiplying everything by 4. 5 times 4 is 20, 20 times 4 is 80, 80 times 4 is 320, and then you're carrying on in that manner. So we say in this particular sequence over here, in this sequence here, we're going to say that R is equal to 4. That's your common ratio. That's what you're timesing by to get from one term to the next. And we're going to use a new notation, which is A. And A is simply equal to the value of term 1. So in this case, A is equal to 5. Right, here's a second example of a geometric sequence or exponential sequence. 7, negative 14, 28, negative 56. So what are you doing to get from one term to the next? You're timesing by negative 2. 7 times negative 2 is negative 14. Negative 14 times negative 2 is negative 28. Negative 28 times negative 14 times negative 2 is 28. 28 times negative 2 is negative 56. So what's your ratio? Your ratio is negative 2. And what's the value of your first term, which we call A? A is equal to 7. So that's what a geometric sequence is. Now we're going to look at the same geometric sequence, and we're going to see how we express it in explicit form, or as a general term, okay, or a general solution. And then we're going to look at that same one and have a look, see how we would express it as a recursive sequence, or as a first order difference equation. So first of all, let's look at the explicit formula. What does an explicit formula do? It generates the value of the term, in other words, Tn, based on its position, n. Okay. So first of all, I'll go right down in that particular sequence, 3, 6, 12, 24, 48. Go write down the value of A, your first term, and go write down the value of R, what you're multiplying by to get from one term to the next. Right. So A is equal to, well, the value of your first term, T1, is 3. And what are you doing to get from one term to the next? 3 times 2 is 6, 6 times 2 is 12, 12 times 2 is 24, which is 48. So R is equal to 2. Okay. Now, you're going to be given this formula over here. Tn is equal to AR to the n minus 1. That is, whenever you got this, that's the formula for geometric sequences. This is for geometric sequences. Okay. Actually, not entirely sure if you get an AP, you definitely get it in core. So it's probably worth learning for now. So just like for, if those of you know, for the arithmetic, it's Tn is equal to A plus n minus 1d. For geometric, you can always use this formula, Tn is equal to AR to the n minus 1, where A is your first term and R is your ratio. So in this case, using that formula and just subbing in, Tn is going to be equal to A, which is 3, R, which is 2, so 3 times 2 to the n minus 1. And remember, you can't go times those two together because they don't have the exponent on them. So there is your final answer. That, ladies and germs, is your explicit or general term for that particular sequence. If you want to check it's working, well, let's take term 4. We know term 4 should be equal to 24. So if I replace n with 4, I'd get, wherever you see n, replace it with 4. The term in position 4 would be 3 times 2 to the 4 minus 1. I've replaced every n with 4. In other words, 3 times 2 cubed, which is 3 times 2 cubed is 8, which is 24. So the formula is working, it's generating that sequence. It's explicit because it's based on n. Your formula is 3 times 2 to the n minus 1. It's generating Tn, okay, based on the value of n. So it's an explicit formula. Right, what about if I do that same formula in recursive form? Well, all you have to say is you have to say to yourself, self, what am I doing to get from one term to the next? And even your average violin teacher would be able to see that you're multiplying by 2. Yes, do you verify that? She gives it the thumbs up, right? We're multiplying by 2. Okay, so I could say the term in position n plus 1 would be equal to 2 times, well, the term before position n plus 1 is the term in position n. So there is your recursive formula. Term n plus 1 is equal to 2 times Tn. Why would we lose a mark if we stop there, if they ask you to give the recursive sequence? Well, because you wouldn't know where the hell to start. Okay, so once again, you have to write down the value of the first term. Now, that's enough information. Those two things combined, using those two bits of information, you can generate that whole sequence. Okay, if term 1 is 3, then term 2 is 2 times 3, which is 6. It's telling you to multiply by 2. Again, you could write it as Tn is equal to 2 times, what's the term before term n? It's term n minus 1. Okay, and then again, you'd have to say term 1 is equal to 3. So those two things are saying the same thing. Right, so if you're asked to find term 20, what would you have to do? Okay, well, it wouldn't be as straightforward as explicit. So you'd have to, first of all, on your calculator, what do? We enter the first term. So you'd go 3 equals, right? Then you would 3, so you'd have 3 equals, press equals. Then you're going to clear your screen. Then you're going to enter the formula. So the formula, now you're going to go 2 times answer. Okay? Right, so in your calculator, you'd go 3 equals, clear your screen. Then you go 2 times answer equals. Now that's the value of term 2, which is 6. So term 2 is 6. Term 1, 2. Term 3 is 12, so it's working. Okay, so I'm up to 3. The next one will be 4. So I'm going to go 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, and you should get 3, 1, 4, 5, 7, 2, 8. Okay, so term 20 is equal to 3, 1, 4, 5, 7, 2, 8. Just, I forgot to do it over here. If I was using the explicit formula to find term 20, well, I had my general formula was Tn is equal to 3 times 2 to the n minus 1. So term 20, I'd replace n with 20, would be 3 times 2 to the 20 minus 1. In other words, 3 times 2 to the 19. And if you enter that into your calculator, hopefully we get the same answer as that. And I go 3 times 2 to the 19 equals, actually, sorry, this T20 should have been that 1572. I must have counted wrong. 1572864. So 3 times 2 to the 19, okay, and 3 times 2 to the 19, yeah, is 157. So that should be your answer, 1572864. Okay, so both methods can generate that answer. That's just a bit tedious because you've got to keep counting, and it's quite easy, like I did there, to miscount. But your answer should be 1572864. Right. So that is geometric sequences expressed in explicit and recursive form. Try to get that down. I'll try to be a bit tidier going forward. Hey, people, try this one by yourself. It's given. So you're given the sequence minus 4, 1, 6, 11, 16, going on forever in that fashion. And the question says, determine the explicit formula for the sequence and hence determine T20. Right, give it a go. So, we need an expression which expresses Tn in terms of n. So what are you doing to get from one term to the next? Well, you are adding 5 in each case. So your difference is 5. Okay, you can use a plus n minus 1d, but I go 5, the difference times n. At the moment, T1 will generate 5, but it should generate minus 4. What do you have to do to get from 5 to minus 4? You have to take away 9. So there's your general formula. Tn is equal to 5n minus 9. And now you want the value of T20. So T20 is simply going to be 5 times 20 minus 9, which is 100 minus 9. And madam, what's 100 minus 9?
100 minus 9 is 3.
100 minus 1 is not 3, it is 91. So that is your explicit formula or your general solution. Okay, Tn is 5n minus 9. Generates the value of the term based on the position in the sequence. Fantastic. Can you touch your nose with your tongue? Yep, okay. Righty. So now you think, oh, this old bag has lost it and he's given the same question, but he has not because he's changed the question. It's the same sequence, okay, minus 4, 1, 6, 11, 16. So you're given minus 4, 1, 6, 11, 16. The question says now determine the recursive formula for the sequence and hence determine T20. Right, give it a go. So a recursive formula generates a sequence based on the value of the term before. So we could say Tn plus 1. Well, what are you doing to get from one term to the next? As we saw before, you're adding 5, okay, to get from one term to the next. So the term in position n plus 1 will be equal to the term in position n, which is the preceding term, plus 5. Okay, so there's your formula. You're not done because that couldn't generate. If I just gave you that, you wouldn't know where to start. So you always have to say what term 1 is, and in this case, term 1 is equal to negative 4. So those two things combined make up your recursive formula. Okay, right, now the question says go find T20. So what do? Well, you've got to use your calculator. On your calculator, you're going to go minus 4, press equals, then clear your screen. Okay, now you're going to enter the formula, and so you're going to say answer plus 5, and then you're going to count. So you're going to go minus 4 equals, clear your screen, answer plus 5, that should give us 1, it does, so that's term 2. Keep then 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20.
Can I teach them a word?
And you should, 1 second, and you should get an answer of 91.
Behest.
Behest.
Behest
Yes, what does behest mean?
is an earnest request.
Here we go, everyone. Did you get that? Behest is an earnest request. I behest you to finish these videos. It is an earnest request. Next one. It says, given the sequence 5, 15, 45, 135, determine the general solution of the sequence and hence determine T20. Okay? I implore you to try this sum, right? At my behest. Okay, so first of all, it's not arithmetic, you're not adding a fixed amount, but to get from one term to the next, you are multiplying by 3. Okay, you're timesing by 3 to get from one term to the next. What do we call that kind of sequence? We are working with a geometric sequence. And if we're asked to find, I know, but they know what it says. It says sequence. I'm getting a look of daggers here. Okay, we'll write it into. a geometric sequence. Get better? Okay? Because it's a fixed, and in that geometric sequence, okay, go write down what the value of A and what's the value of R. A is the first term, R is the common ratio, in other words, what you times it by to get from one term to the next. So tell me what A is, tell me what R is. Right, so A is equal to 5, and your ratio is equal to 3. And for a geometric sequence, okay, we want to, black pen, these black pens are coming dodgy. Okay, then we need to know this formula, we need to learn it. The term in position n will be the first term times the ratio to the power of n minus 1. So to get the general sequence, the general term, the general formula, the explicit sequence, all same thing, will be 5 times 3 to the n minus 1. You can't times that together. So that is your solution for the first part of the question. That's the general solution, the general term, the explicit sequence. Right, now they said to you, hence go determine T20. So you simply, wherever you see an n, you replace it with 20. So T20 is equal to 5 times 3 to the 20 minus 1, which is just 19. And if you enter that into your calculator, 5 times 3 to the 19, you should get an answer of, now here's a challenge for ma'am. If she can read this, I will make dinner tonight. 5, 8, 1, 1, 3, 0, 7, 3, 3, 5. So if you had to read that number out loud to somebody, what would that be? This is a competition between Madam and the original rat bag, otherwise known as Kyra. How would you read that out loud? Kyra, go. Madam, go. No, not trillion. Divide it up. I always do that, going from that side to that side. So it's going to be 5,811,307,335. And don't worry, Ratbag didn't get it right either. Or is it either or is it either?
You say potato.
True, true. Right, get that down.
You say tomato.
What does the song go? It's 9 o'clock on a Saturday. Dun, dun, dun. But this is actually, it's 10 to 6 on a
Thursday.
That's it. Okay.
Here we are all for maths.
Yes, here we are all for
And
maths.
we love to
Okay,
see.
right, so you're given 5, 15, 45, 135. Okay, it says determine the first order difference equation. Ooh, determine the first order difference equation of the sequence and hence determine T20. So it's the same question as last time, but not the same because we changed the question. You know what I mean, the numbers are the same. Okay, but now we want that same sequence, not as an explicit, but as a recursive sequence. Remember, first order difference equation is a recursive sequence. It's a recursive sequence. It depends on one term before it. Okay, still a geometric sequence, obviously. So in recursive language, we're going to have Tn plus 1 is equal to. Right, so what are you doing to get from one term to the next? Well, we're still timesing by 3. So a term in position n plus 1 will be equal to 3 times the term before that. And that's it. Okay? Right, are we done? Not quite, because we've got to say what the value of term 1 is, and term 1 is equal to 5. So that, over there, is my first order difference equation. Right, then it said we have to go find T20, so we're going to have to use our calculators to do that, pressing the equal button over and over again. What do we do on my calculator? On your calculator, you're going to go, pen's driving me mad. Okay, on your calculator, you're going to go into the first term, which is 5. Okay, then you're going to press equals, and you're going to clear your screen. Okay, and then you're going to go answer. Press the answer button, and you're going to multiply it by, what are you doing to get by 3? Okay, so you're going to go 5 equals, clear your screen, then you're going to go answer times 3, which should give us 15, and that's term 2. So now it's just a question of counting correctly. So I'm on 2, so 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Haha, there it is. I think it's the same. 5, 8, 1, 1. Is that what we got last time? I think it is. Praise be, it is. Right. So the answer then.
Andrew's eye.
I just put my pen in my mouth. It's disgusting. Term 20 is going to be equal to 5, 8, 1, 1, 3, 0, 7, 3, 3, 5, which, as the informed will know, we read as 5,811,307,335. Don't you all think I would make a fantastic president of the country? Right, the next one. Given. Okay, so it's actually pretty straightforward. You're given the sequence this time. So it's a recursive sequence. You're told the term in position n plus 1 is the preceding term, term n plus 7. And the first term, t1 is equal to 4. Determine the sequence. So when they say that, when they ask you to write down the sequence, determine the sequence, okay, you generally just go write down the first 4 terms. So they've given you, so go try to do that, go write down the first 4 terms. Okay, so your first term is 4. What do you have to do to each term? You have to add 7. 4 plus 7 is 11. 11 plus 7 is 18. 18 plus 7 is 25. And that, ladies and germs, is your answer. Right, try the next one, please. Given Tn plus 1 is equal to negative 3 times Tn, and term 1 is equal to 2, the question is, write down the sequence and determine T18. Off you go, write down the sequence, simply means write down the first 4 terms. So, the first term they give you is 2. The next term is going to be 2 times negative 3, which is negative 6. Okay, so it's 2 times negative 3 is negative 6. Negative 6 times negative 3 is positive 18. Positive 18 times negative 3 is going to be negative. 10 times 3 is 30. 8 times 3 is 24. So it's negative 54. So that's the first part of the sequence done. Write down the sequence. Now you're going to find T18. So what you're going to do, you're going to use your calculator. Enter the first term. So you're going to go 2, enter equals, clear your screen. Okay. And then in the calculator, you're going to go negative 3 times answer. And then you go equals, 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 count it, count it, count it. And you should get an answer of a monster number, negative 2, 3, 2, 4, 5, 2, 2, 9, 3, 4. If you got it correct, high five yourself. Okay, how would I read that? We'll count backwards in 3s. Okay, there's your hundreds, there's your thousands, there's your millions, there's your billions. So it'll be negative 2,324,522,934. Lovely. Right. Your next question says, given the sequence 1, 5, 17, 53, 161, and then it says the sequence above is a first order difference equation, in other words, a recursive sequence that depends on one term before, of the form Tn plus 1 is equal to k Tn plus c. Determine the value of k and c, and hence determine the value of T20. Now, sometimes we won't tell you this. In grade 10, I think we probably will most of the time. Okay, but it's a first order difference equation, and you're not simply adding a fixed number. There you're adding 4, there you're adding 12. So it's not arithmetic, it's not geometric, and it's first order. So then what you're going to be doing is a combination of, to get from one term to the next, you're multiplying by a fixed number and then adding a different fixed number. Okay, so those are the more complicated ones. Okay, so just get the question down. Right. So there's a summary of the question. So we've got term 1 is 1, term 2 is 5, term 3 is 17. Okay? Now we're told that Tn plus 1 is equal to k times Tn plus c. So using that logic, term 2, if n was equal to 1, then if I sub in n is 1, I get term 2 will be equal to k times term 1 plus c. But what is the value of term 2? Term 2 is equal to 5. So you're going to get 5 is equal to k. And what's the value of term 1? Term 1 is 1 plus c. Okay? So I get 5 is equal to k plus c. Right? Now I want to do the same thing, but using n is equal to 2. So if n is equal to 2, then term t plus 1, n plus 1 will be term 2 plus 1, which is term 3, will be equal to k, sub in 2, times term 2 plus c. But what is the value of term 3? It's equal to 17. So you'll get 17, it's a wolf coming to eat 17. 17 will be equal to k times 5 plus c. In other words, 17 is equal to 5k plus c. And now what's your objective? It's to solve for k and c, and you've just done simultaneous equations in core. So here's your one equation. Let's just isolate one variable. Let's say k is going to be equal to 5 minus c. Let's call that equation 1. Let's call that equation 2. And if you use substitution, go try to solve those two equations simultaneously in order to get k and c. Right, so if I sub 1 into 2, you're going to get 17 is equal to 5. Well, k is equal to 5 minus c, so I replace k with 5 minus c. So 17 is equal to 5 minus c, that's k, plus c. So 17 is equal to 25 minus 5c plus c. So 17 minus 25 is negative 8. Negative 5 plus 1 is negative 4. So negative 8 is equal to negative 4c. Divide both sides by negative 4. And I get 2 is equal to c. We're not quite done. We've got to find the value of k. But c is equal to 2. If I sub into 1, I get k is equal to 5 minus 2. So k is equal to 3. Right. So now, that was the form of the first order difference equation. I've got the value of k and the value of c. So in general, I know that term n plus 1, it asked me for the formula, to be equal to 3, because k is 3, times term n, plus c, which is 2. And we also know that term 1 is equal to 1. Right. Now I want you to use that and do the next part of the question, which is to find term 20. Okay, term n plus 1 is equal to 3 times term n plus 2. Go find term 20. And you're going to use your calculator. What you're going to press, you're going to go 1 equals, clear it, and then you're going to go 3 k times answer plus 2. Okay, and you're going to keep pressing equals. Okay, so you're going to go 1 equals, clear your screen, 3 times answer plus 2 equals, check if it's working. Well, I get 5, which is great. So that's term 2. Term 3, 17, it's working. Okay, term 4 is 53. And term 5 is 161. So I'm up to 5. I've got to get up to 20. So 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And you get another monster number. Yep. So you get T20 is equal to 2, 3, 2, 4. 2, 3, 2, 4, 5, 2, 2, 5, 2, 2, 9, 3, 3. Count backwards in threes. It's going to be 2,324,522,983. Lovely stuff. Very common type of question. Okay, guaranteed to come up in tests and exams. Oh, that got your attention, didn't it? And you'll be pleased to notice the last example for the term. And this is a mixed sequence, which is a combination of an explicit, in other words, it depends on the term, on the position of the term, and recursive, in other words, also depends on the value of the term before. And it says, go find the sequence if Tn plus 1 is equal to 3 times the preceding term plus 5 times the position n. Okay, so plus 5n. Okay, so these are just take just a bit of careful. Go try and do it, but it takes just a bit of thinking. So we need the first, to find the sequence, we need to go find the first 4 terms. So term 1 is 2. Now, if n is equal to 1, and we sub it in, we'll get T1 plus 1, which is term 2, will be equal to 3 times term 1 plus n is 1, so plus 5 times 1. Right? So term 2, but what is term 1? It's term 1 though is equal to 2, so term 2 will be equal to 3 times 2 plus 5, which is 11. This is our last example, Amber, promise you. Then we're done. Somebody's getting very frustrated with me. Okay, but they have been very patient, and they will be thanked with chocolate. Right. Now.
As you need to thank me with my macaroni cheese.
And with your macaroni cheese, yes. Whew, a lot of bribing going on in this house.
And you still owe me 300 rand.
And I still owe you 300 rand. For no real reason, but still.
No, you made a deal with me.
Okay, right. The next one. If n is equal to 2, then what does this become? Term 2 plus 1. What's 2 plus 1, Amber?
3.
So term 3 will be 3 times, n is 2, term 2, replaced n with 2, plus 5 times n, so plus 5 times 2. But what is the value of term 2? Term 2 is equal to 11. So term 3 will be equal to 3 times 11 plus 10, which is 33 plus 10, which is 43. Right, so I've got the first, let's just do one more. Okay, so if I look at the scenario when n is equal to 3, try to do that one if you haven't done it. Okay, go sum in n is equal to 3 and find the value of the fourth term. Give it a go. So if n is 3 and I sub into that formula, I'll get term 4 is equal to 3 times term 3 plus 5 times n. Okay, tell them what I do all day, Abrin. Work. So term 4 is going to be equal to 3 times, what's the value of term 3? But we're nearly on holidays. 43 plus 20, which is going to be 40 times 3 is 120, plus 3 is 129, plus 20 is 149. I think that's right. Is it? 3 times 43 is 43. Yeah. Plus. Sorry, n was, my deliberate mistake is what happens when I'm talking. N is 3, so that's 3, so that's 15. So 3 times 43 is 129, plus 15 is 144. So the question was, go write down the sequence. So the sequence, your final answer for the term is going to be 2, the first term. List the sequence. The question said generate the sequence. So it's going to be 2, 11, 43, 144, and all that's left to do is to tell you what you're going to be doing on your own, but get that work of art down. Right, the last thing to do, okay, I want you to read through your mind-born maths in the red one, okay, the modelling textbook. I want you to have a look at the examples, page 99 to 106, and the notes. Don't have to write them down there. Then I want you to do all of exercise 1 on page 105 and do all of exercise 2 on page 107. I'll send you the work memo. And then, ladies and germs, your term work is done. And I would just like to say thank you for being such awesome rat bags. Okay. And I think tomorrow I will shave all my hair. Stay safe, stay sane, be nice to your family, okay, and be good. Adios, amigos.